How are you doing? Thank you so much for joining me with another math lesson with Mr. Whitford. Today, I'm going to go over lesson 4.2 with you in our new unit, unit 4, modeling geometric figures. Today, we're going to continue off with where we left off in unit lesson 4.1. However, instead of calculating perimeter and area of just regular rectangles, I want to do some unusual shapes that will break off into rectangles, if anything else. All right, so do me a favor. Follow along with me in your actual packet. Turn to lesson 4.2, which is calculating perimeter and area of unusual shapes. As usual with every video, every lesson, take a moment to pause the video now and begin to work on the bell work. All right. I hope you had enough time to be able to work on the bell work. As you notice in the bell work, both A and B, there is no image there. But what I would like you to do, as I mentioned in the last lesson, is draw yourself some rectangles if you need it. If you don't need it and you're able to do 2 times 4 plus 2 times 2, and you would get 8 plus 4, you get 12 for the perimeter. And if you did 4 times 2 and you got 8 for the area, that is A-okay, okay? Over here for B, you would do 2 times 7 plus 2 times 1. You would end up getting 14 plus 2, which is 16 for the perimeter. And then you would do 7 times 1, and you would get 7 for the area. Right? Today, I want to talk about unusual shapes. Now, what is an unusual shape? It's a shape that does not, there are words called convex and concave. I'm not going to introduce those words fully to you yet until we get into another lesson, which deals with the images that are really warped. But think about it like this: unusual shapes are shapes that they don't have a name for them. Up until this point in your math, we learned squares, rectangles, rhombuses, parallelograms. Those are names that you know because you can recognize those shapes right away. But an unusual shape, you can't really name it. You could name it based on its sides, how many sides it has. But for now, let's just call them unusual because they're not your typical cookie cutter shapes, to say. Okay. We talked about area and perimeter last time. The formulas are still the same. If you want to calculate perimeter, you could do 2 things. You could do 2 times length times width. 2 times length plus 2 times width. Or you could just add up all the sides for perimeter. For area, we know it's it's 2 length times width, which is going to give us the actual area of a rectangle. And these are rectangles I'm talking about. When I look at the shape that's in modeling, if you look at it, you notice it looks like, I guess, let's say a stairs, right? Stairs going up to something. But what I notice here is that this particular image can be cut into 2 different pieces. It can be cut into 2 different rectangles. Now, there's a couple ways you can cut it. You can cut it. I'm just going to use the dotted line here. Right? You can cut it across this way. Right? Sorry, that's not a straight line. Or you can cut it even down this way. Either way that you cut it, it can begin to create 2 rectangles. Now, right now, the way I cut it, it creates 3 rectangles. But I'm going to only use 2 when I go to use it. Okay. Before I go to deal with cutting it, though, let's talk about the perimeter. Let's talk about perimeter. We know perimeter is all the outside, while area is all the inside. The way I'm going to calculate the perimeter is I'm going to add up all the sides. So 3. Oh, let me get rid of that. My apologies. I'm going to change it back to solid. Okay. So 3 plus 4.5 plus 5.2 plus 3. And then if you notice here, this side is missing. I don't have a number for this side. And I'm also missing this side here. I don't have a number for. So before I can go and calculate, those are questions. Before I can go and calculate the perimeter by adding up all the sides, I actually first have to find this blue question mark and I have to find this red question. Okay. I have to find these 2 missing sides. Okay. Now, how do I do that? The way I'm going to do that is I'm going to use the dotted lines that I originally drew. I'm going to bring them back. So let me draw a dotted line across this way first. Okay. That's my dotted line across that way, and we just put it back to being solid. If you notice, just gonna get rid of this one here because I want to find the blue one first. I want to find this one. If you notice, this side is really the same length as the one at the bottom. There is a property of a partition, if you will, called the addition partition, right? Where it's saying two pieces add together to give you a whole. Or you can use subtraction to find the missing piece, if that makes any sense. 5.2 is the full length of this line. Whereas if you look at the top here, the top is 3 and we need this missing one. So in all actuality, if I were to extend this out, this would really be the same as the question mark below it. So I'm saying 3 plus what? So 3 plus this question mark has to equal 5.2. Okay. Now we're going to talk about in our next unit solving for one-step equations, which looks just like this. Instead of a question mark, we're going to put a variable. If you remember, a variable is an unknown letter, right? We're going to use subtraction here to get rid of this positive 3, subtract to the other side, and it's going to give us this question mark. So we really need to do 5.2 minus 3. And I put 3.0 because I want you guys to remember that's a decimal there. So decimal 0 will give us the same value. Okay, and when I subtract it, I'm going to end up getting 2 minus 0 is 2, 5 minus 3 is 2, keep the decimal in the middle. So this question mark is really 2.2. So let's add 2.2 to our calculating of the perimeter. This is equaling the perimeter, okay? I have to find this other missing piece over here as well. I have to find that other missing piece. I'm going to use another dotted line. Let's make this one red this time. Let's make one blue. My apologies. Dotted line is gone. Okay. So now we can get rid of this dotted line. Okay. And once again, I notice that this full line here is the same length as 4.5 over here. Okay. So now what I'm working on is I want to figure out this length right here. I want to figure out this length. I can do the same thing over here, saying that this additional part of the line is actually that same question mark I need to figure out. Same exact question mark I need to figure out. So what I'm going to do is say, okay, 3 plus something, right, has to equal 4.5. Once again, I'm going to subtract 4.5 minus 3, and that's going to give me 1.5. So I know that this question mark here is really 1.5. Whereas this other area down here is really 2.2. Okay? That's your first step when you go to do this. You first need to find these missing lengths. Now that I found the missing lengths, now I can go right about it and go and calculate the perimeter. When I add up all of these sides, let's see what we get. And I'm going to use my calculator here because I actually didn't get a chance to calculate it beforehand. 3 plus 4.5 plus 5.2 plus 3 plus 2.2 plus 1.5. And that gives me 19.4. So 19.4 is my perimeter. Since they do have the letter M next to it, I'm going to say 19.4 meters is my perimeter. Now we do have to find area. Now the way we're going to find area is we're going to use a dotted line again. And it doesn't matter which dotted line you decide to use. I'm going to use the one that's going straight across here. Imagine if that was straight. Let me try to do that one more time. I'll try to make it a nice straight line. There's some tools here I can use. Let's use this one. Boom. Okay. Notice what I did here. I actually separated this rectangle or this unusual shape into 2 rectangles. One rectangle up here, one rectangle down there. Now, what I'm going to end up doing here is I want to find the area. I'm going to find the area of 2 different rectangles here. I'm going to find the area of this rectangle below. Okay, and I'm going to use the length. That's the width. I'm going to use the length times the width to find that one. So it's going to be 5.2. Now let's use a different color. I don't want to confuse you with all these colors that look the same. Let's use green to find the area. Area is going to be green. 5.2 multiplied by 3. Because you know area is length times width. Now this is going to be the area of the big rectangle. So let's call that B. This is the area of the big one. Okay. So the area of the big one, when we do 5.2 times 3, that gives us 15.6. That's the area of the big one. Now that's not your area down here. The reason why it's not your area down there is because there's two rectangles you got to calculate the area for, not just one. Okay, so we got to do it for 2. Let's do the area of the smaller one. Let's call this S. Okay, so the area of the smaller one is going to be length 3. Everybody see 3 there? And I'm just going to underline this in red. 3 multiplied by 1.5. Okay. Now, when I do the area of this one, it's going to give me the smaller one. 3 times 1.5 is about 4.5, I believe. Just check. Okay. 4.5. Now I have the area of the smaller one. I have the area of the bigger one. The thing is, because I want to calculate them together, I'm going to add them together. So I'm going to do 4.5 plus 15.6. Okay. When I add them together, I just want everybody to see what I did. I did 15.6 plus 4.5. When I add them together, I get 20.1. Now we are talking about meters, so make sure you put meters squared. Now, why is it meters squared? Because as area, we do meter times meter, which gives us meters squared. Okay, this is what you're going to end up doing today. You're going to find the perimeter and the area of unusual shapes. It's going to take a little bit of time. You're going to have to find the missing sides first, then calculate the perimeter altogether. My recommendation when you're finding perimeter is just add up all the sides. You could separate the 2 rectangles and then do 2 times length plus 2 times width, but you also got to do that again to the other rectangle and then add those 2 numbers together like we did with the area. But I find it easier just adding up all the sides after you find the 2 that's missing. Then when you're calculating area, separate them into 2 rectangles, just like I did. Call one the big rectangle, call the other one the small rectangle. Use the length and the width. Notice here, ladies and gentlemen, I did not use 4.5 for either one of these rectangles because I see that 4.5 is shared. I want just the side of this one and just the length of this one. All right, that's going to help me be able to find just the area of that small one, and the same thing with the bigger one. All right, so that's it for today. Take your time, go through practice. If you need to pause the video, rewind it, watch it again, please feel free to do so. As usual, put any and all questions that you have on the Google Classroom page. And I look forward to helping you guys learn. Thank you so much for joining me with another math lesson. Have a wonderful day. Bye-bye.